Awesome. We'll get started in like 2 minutes. For those of you just joining, there will be, or you should be able to see a GitHub repo in the chat that you can clone. And that's what I'm going to be running through, so you can follow along there. The other thing while we're waiting is we are in the midst of Hacktoberfest, and someone doesn't see in chat. Chat, if you make me host, I can resend it.
So I think you are the host right now.
Cool.
But
I'll send it now. I just posted in chat again. We are in the midst of Hacktoberfest, by the way. So if anyone is interested in building onto some of the things that we've done, want to add on and build, let us know. We'll be able to point you in the right direction. Great. Awesome. Huge turnout. Let's get started. So I'm going to make this full screen, and then I'm going to put it next to my stuff. Okay. So today, we're going to do a lot of fun things. We're going to build a chatbot on a podcast app, or rather our podcast, the MLOps Weekly podcast. And it will actually use some of the transcripts from that podcast to contextualize a prompt and do RAG. So RAG is kind of the new hot word after LLMs. RAG is retrieval augmented generation. We will talk about what that means, talk about how to implement it, and we'll run it end-to-end of Featureform. Awesome. If there's any questions along the way, please feel free to drop in the Q&A. I will be looking, there will be kind of natural stops throughout this, and I'll do that to answer your questions. Without further ado, and again, like if you haven't yet, take some time to clone that GitHub repo. We're going to be using Weaviate. If you go to Weaviate Cloud, you can build an account or create an account there and create a sandbox. It's free, a sandbox one. You'll also need your OpenAI key and your OpenAI org. And there'll be time when we'll go through this, but if you don't have an OpenAI account with billing enabled, or if you don't have a Weaviate account, then you won't necessarily be able to follow along like by running it. You should also clone the repo. But you'll be able to I'm going to run through it. I'll explain everything. So even if you can't run it now, you could always clone and do it on your own time as well. Great. Let's share some slides. So let's talk about RAG. Let's talk about LLMs. Let's talk about Weaviate and vector DBs. Let's talk about all this stuff. Today, we're going to go into Featureform. We'll talk about what Featureform is. We'll talk about LLMs. There's this idea of zero shot, few shot, and fine tuning, or many shot. which we'll talk about. We'll talk about what RAG means in that context, which is really, RAG is really just a way of how do I use my data, my private data, or any data I have in an LLM app. I called it an end-to-end demo, but really it's a workshop. So there's a notebook you'll be able to follow along, or you can just watch. It's kind of up to you. But we do set this up in a way where you can follow along. In the end, we will leave time for questions. I'll talk about, as you want to build and expand on this, how to get support, how to issue tickets, how to give us feedback. Awesome. Let's do it. So I'm Simba, founder CEO here at Featureform. I started Featureform at this point many years ago. Prior to that, my background is actually more in recommender systems. I built a recommender system that powered about 100 million monthly active users experiences. They personalize it. That recommender system was using embeddings. We built a vector database. So embeddings and the whole concept around it is something that I've personally been working in for a long time. Obviously, LLMs are much newer, but we were using transformers back then. It isn't how GPT is today, to say the least. And RAG has kind of been very interesting to watch form because it's kind of a combination of a lot of things I've used kind of come together. So I'm hoping in this talk to, one, give you really clearly what is RAG and how do I do it? And two, just give a little bit of context and history on why RAG is even something everyone's talking about, why it works so well. So before that, let me explain what Featureform is. Featureform is a way to define, manage, and run your data pipelines. Really define, manage, and deploy those data pipelines that you use, whether it's for streaming, whether it's LLM focused, whether it's running locally on your laptop, whether it's on some giant Databricks cluster. It gives you versioning, reuse, search and discovery, and much more. Essentially, it's how do you connect your data to your models, whether those models are traditional machine learning models or LLMs. So maybe let's talk about, because there's obviously, let's talk about where we started and where we've come. So this is kind of how ML is done traditionally. You'd work in a notebook or across some scripts. You'd interact with your data sets. You would use that to build features. Features are just signals. They're like inputs to a model. And then the model would make a prediction. Now, typically, these features would just be floats. And the model would be something like a random forest, maybe a deep learning model. This has all kind of changed for AI-based or LLM-based applications because the features now are text. And the model is a much different beast, much bigger, much different behavior, and a lot harder to kind of figure out and debug. The problem that we see, even in traditional LLMs, or in LLM applications and traditional ML, is something like this. If you've been working with LLMs in production, or you've just been messing around, this might look kind of familiar to you. It's really common. We see all the time where there's no process on how do I come up with good features or good context. How do I iterate on these things? How do I manage them? How do I document them? How do I build a production grade data pipeline for my ML models? And in practice, we're not really good at it yet. Like these are things I see all the time. And honestly, before Featureform, it's things I would do quite often. The other big thing we run into, if any of you have kind of thought about, okay, cool, I built this cool let's say AI application. I got it to work. How do I get this in production? How do I work with streaming data? How do I get this over a much larger data set where I need Databricks? How do I handle all the things that I need to actually power my AI application or ML model? And so these two parts, one is building a workflow, a process for the data part of machine learning. And two is making deployment dead simple and unified so that you don't have different pipelines for experimentation and different pipelines for production. Those are kind of the two goals that we set out to solve with Featureform. Because we're really trying to make sure that your features are usable everywhere and that there's this one clear pipeline. The name Featureform comes from Terraform, because when I originally built Featureform, what I wanted was Terraform for features. Awesome. So I'm going to come back to this, but I want to now talk about LLMs. Or I guess one last thing before I go entirely into LLMs and talk about RAG. Historically, there are three kinds of features, or I guess as of today, there are three types of features. There's analytical features, which are typically numbers, could be like your age, it's an analytical feature. Embeddings, which is this new type of thing, which we'll talk about. These have actually been around for a while, and recommender systems, we've used them for many, many years now, as well as NLP. And then prompts, which is a whole new thing, which only applies to LLMs. In the process of LLMs, all of these things are just used to give context and intent to an LLM. So all these things fill together to tell the LLM and maximize the amount of information you get it that it can then use to make a prediction. So let's build up from how we use LLMs, the base LLM operation, and what RAG looks like. So the base LLM operation, this is like if you go into ChatGPT and you start writing to it, you're really writing a prompt. You might in your head have some sort of like prompt engineering where you will kind of structure your question in such a way to make the LLM do what you want. So you might copy and paste code, you might put quotes, like there's some kind of really basic things you might do. You'll give it to the LLM will come up with a response. This is the base operation, and it's often called a zero-shot operation because you're not giving it any information or any training. You're just trying to see how it does with all the information it has pre-built into it. It works really well, actually. Like in many situations, this is good enough. It kind of feels like magic. This is why GPT has kind of continued to grow and has been a huge kind of step change in how AI works. But the cons is it hallucinates. It has stale data, like it's only trained up to a certain point. So if you ask it about current day events, it will have no context. If you ask it about your code, it won't know what your code is. You'll have to copy it in. The responses are undifferentiated. So if you're building an application, you kind of probably want it to do better than just what ChatGPT would do by default, which typically means giving it data of some kind. And 4 is, again, it doesn't have context. It doesn't really know what you're talking about unless it's something that's really generic that has a ton of, has been trained on. Like if you ask it about your code base, it will have no idea what your code base looks like or what it is. So there's this idea of fine-tuning or many-shot, where you give it a lot of prompts and you give it a lot of responses and you just fine-tune. So you say, hey, here's a question or a prompt. Here's a response I would expect. And you can go through this and you're essentially training the model, very similar to how traditional machine learning works. Obviously, it's slightly different. It's a pre-trained model and you're really fine-tuning it. You're not actually training it from scratch. But it looks like traditional machine learning. And so a lot of people, when they get into LLMs, this is one of the first things they try to do. They just try to fine tune because it feels like kind of how we've historically done machine learning. So the benefits, you can use a ton of data. Like you can fine tune a lot of data if you want to. It looks like an ML pipeline. And you can use human feedback. Like you can actually use data from your application or just from yourselves to really give it and build the best training set possible to differentiate and create the best possible experience for your end users. Now, the cons is 1, it still actually tends to hallucinate. 2 is fine-tuning isn't usually as good as memorization, or it's not good at memorization. It's typically more like style, like it learns the style that you want you to respond in. and much less it remembers specific numbers and specific facts. It requires you to have a good data set and a lot of data that's kind of generically usable. And 4, and this is usually the biggest one, especially with enterprises, is it's really subject to prompt injection. Anything you fine tune with is kind of part of the model. So any prompt that is asked, you can be attempting to get your training data. So if your training data is like private data of specific users, someone can ask a prompt and get that data. There is no like walled garden between different users. All of people's data live in the same fine-tuning layer. And finally, we get into RAG. And obviously, this is most of what we're going to talk about from now on. RAG is this idea where you use your data and you feed it into your prompt at request time. So it's like that idea of prompt construction where you take a prompt and you feed in context, but you're doing it programmatically. And you're typically using something like a vector database, which we'll talk about, as well as its typical features. And so that builds a contextualized prompt, and then that is what is fed into the LLM. The pros here is it has a much lower risk of hallucination because you're really giving it all the context it needs in that request. So you can really set the guardrails right there. It's safer from prompt injection because all the private data you're feeding in is just in that conversation, so it won't be used in other conversations. It tends to work really well, which is kind of why it's really taken the world by storm. And 4, is that it's very easy to iterate on. Like you can continue to iterate and evaluate and make your prompts better. It looks like feature engineering, much more so than other things you might have done in the past. The cons is it's complex. As you saw, that picture is way more complicated than all the other ones. And 2 is it requires enough data to be able to actually contextualize any conversation. If you don't have that, if you don't have data, then you kind of are stuck with this debate. Just ask ChatGPT directly. If you have context, though, you can start to do this stuff. So fine-tuning is about style. RAG is about content. Fine-tuning needs a lot of data, typically. RAG can kind of work with any sorts of data. Fine-tuning tends to be more prone to hallucination, while RAG tends to dramatically reduce hallucination. Fine-tuning is very simple, and RAG is quite complex to build. These are the main differences. And again, your mileage may vary. Like you should try it for your use case and see what works. My sense is if you're really trying to get the style and you have data of what you want the style to be, fine-tuning works really well. And otherwise, RAG is typically where I would start. That said, they're not mutually exclusive. It's very common to do both. You might use fine-tuning to really make sure it works well and that you really get the style right while using RAG to allow your responses to be better with more context. So let's break it down. The user asks, let's say you're a bank, and the user asks you, how should I be investing? You might retrieve a set of analytical features. Like you could just ask ChatGPT, how should I be investing? It will give a decent response. It'll be very generic, very vague. But if this is your user and you're a bank, you probably know their age, you know how much money they have, you know what they're spending. You can retrieve all of these features and feed it in as context to allow the LLM to do a much better job without the user having to copy and write this stuff all out. 2 is you might have your own internal content, maybe from conversations of your employees, that shows your take on the world. Like every bank, might have a slightly different take on what the answer is here. And so you can take your own content and get relevant content and feed that into the prompt as well. And so the final prompt looks like, given the user has these attributes and using this content from our blog as context, answer this question. So what RAG did here is it took the question and it contextualized the prompt and then gave that prompt to the LLM. Now, how do you implement this? There's two parts. One is building the context cache, which is really just taking your documents, taking any of your data, building your features, building your kind of content database. For content, we use a vector database because we want to be able to get similar content. Like, based on this question, give me content that is similar or relevant to the question. A good trick to do that is take your content, create an embedding, put it in a vector database. Embeddings that are similar are typically relevant to each other. So if I take an embedding of my question and I have a document which has a similar embedding, I can assume that these things have high affinity towards each other. So they're likely relevant. And then for inference, an inference store, that might just be lookup by user ID. So a vector database is a similarity search, and the inference store is like a key value search. You could combine both of these things. This is your context cache. So this data set is kind of what gets combined into your prompt. Per request, whenever a user makes a request, you need to get the relevant content for that request. So you might take the query, you might create an embedding out of the query, find relevant content to that embedding. You might take the user ID, go to the inference store, grab the relevant attributes or features of that user, and then you feed them together into the prompt that you give to the LLM in the end. So that's RAG. There's kind of this offline part where you are taking all your data. That data might be changing, it might be updating. You are feeding it in, you are filling up your vector database, filling up your inference store, and then you're creating a contextualized prompt from it. The whole point of the vector database, just to be really, really clear, is just to get relevant text content. It's really just like a, hey, given a query, can you give me content that is relevant so I can feed it into my prompt? That's really the role of vector DBs in LLMs. It seems kind of random, right? Like, why would vector DBs become this huge category given all they're being used is to get relevant content? The reason is, in practice, it works really, really well. That's all. Like, even though it sounds random and it sounds simple, in practice, it's what's been working the best. And it's almost always the first step to get a ton of performance gain on your LLM application. And like I said, embeddings are just a way to get similarity. So things that are similar will be close together in embedding space. Vector DBs have just one operation, which is nearest neighbor. So given an embedding, give me the nearest neighbors to that. And that happens to be like similarity. Any questions so far? I see a few just came in. What about indexing? Does embedding sometimes, is it sometimes overkill on accuracy? And can we use embedding live every time a user asks a question without saving them in the vector DB? Yeah, so the way a vector DB works is, you know, like in a key value store, you might have by the way, I see some people are trying to ask questions. In Zoom, you can just hit Q&A and put your question in there. So there's like a part on the bottom where there's Q&A. But sorry, coming back to this. So the question is, can we do embeddings live every time you ask a question, or do we save them in vector DB? How you do it in practice is for the content you already have, you're gonna index that. And really what indexing means is putting it through a model that creates an embedding. So in a key value store, right, you might hash some text and then you can do a lookup on the hash. In embedding space, you're still kind of like hashing the data, but this hash is not a like one-to-one lookup. It's more like a fuzzy lookup, like give me things similar to this. So what you end up doing is that you embed or hash all of your content that you have or all your data. And then at request time, you hash just the user's query that came in that you wouldn't have had before, right? And then you do a lookup, like given this embedding, find me other embeddings like it, and then you grab the content from those embeddings. And this, is it sometimes overkill? Maybe. I can't answer that because it really depends on your use case. Is it sometimes overkill? Yeah, I mean, you could just use the base case that we talked about, right? You could just give it no context. But if you want to give it context, doing a similarity search is what's going to work. There are other ways to get similarity search. So there's another question, which is, how about if a new document is added? Well, what you'd have to do is create another embedding, update the vector database. And so Featureform is used to do that. Like Featureform is the data pipeline. You specify the pipeline, and every time the data changes, everything gets updated. But in practice, if you don't have Featureform, you would have to build your own code to do those updates, keep track of different ways you're embedding things, and even the way you decide which documents to use, how you break those documents up, et cetera, is like it's a variable. Do I have to add the training data to a vector DB on all of the data I have? No, but any data that's not in the vector DB just by nature can't be looked up. So you can't do it like lazily in the sense of you can't just like build all of the user embeddings at that point in time or all the training data in that point in time. You kind of have to pre-process it. That said, sometimes it might make sense to only pre-process a smaller amount of your data, and it kind of is a little out of the scope here. But it's just whatever's in the vector DB, you need to, the index is the key, is the embedding rather. So the key to look things up is the embedding. So if you don't build an embedding, you can't do a lookup. And if you can't do a lookup, you can't use it in your prompt. Yeah, so is there any best practices on how to incorporate structured fields into RAG? So great question. I think this is something we don't talk about enough, which is that some of the most valuable things you can do with RAG is actually like going back to here, like some of these analytical features, like age, money in your bank, average spending per month, those might be in like Redis or Dynamo, not in the vector database. Which ones do I use? Is there best practices? This is like kind of the art of AI and ML. Like this, it's nice here because it's natural language. It's kind of like, what features can I come up with that are most likely to allow the LLM to do a better job? And like, if I think of like, how should I be investing? Like, that's a question. It's like, what relevant features, what things would I want to know about the user to answer that question? Like, what context would I want? And just get all those contextual variables, feed them to the LLM. What's the difference between the inference store and a vector DB? So the inference store is for key value lookups. So like the age, right? Like a user's age, that will be in the inference store. Because you just get the user ID and you use that to get the age. You don't need there's no embedding, right? You're just getting a user ID to get the vector DB here. In terms of contextualization, it's like the contextualization in this case, the question I ask is, how should I be investing? Imagine someone asks you that question. Think of what you would want to know about them. Like, how old are you? How much money do you make? How are you investing today? What's your risk profile? Like, you'd have these questions you'd follow up with. And you can take the answers to those questions, because you might have them in your databases, and give them to the LLM as context. That's what contextualization means. So you're giving the LLM more information. You're optimizing for the information you provide in the question so that the LLM could do the best job possible. Someone posted a collection of vector databases, which we're going to share some stuff after. We support Pinecone, Weaviate, Milvis. There's probably more I'm forgetting, but we support a lot of them. And we actually have some open tickets to implement some of the others in Featureform. So if that's something you're interested in, let us know. A lot of questions, great questions too. Thank you. Okay, I'm going to show you code so we can actually like really look at this for real and build a RAG application. Okay, so what do I have so far? I have a Weaviate database, which is not on this tab. It's on, I guess I got signed out. Okay, well, I have a Weaviate cluster running. I have this notebook, which again, we've included in chat if you want to follow along. And I also have an OpenAI account with billing enabled. I created a .m file. So like, if I was to show you, I could do ls and then grep. Oops. It's weird. ls-a because it's a hidden file. Or not. Weird. Okay, so I have one file in here, which is my .m file. I'm actually going to verify it's actually there, and I'm not going to find out the hard way it's not there. 1 second. So it is there. Awesome. Okay, so first thing I'm going to do is run this. All this is going to do is from my .m file, it's going to get my Weaviate URL, my Weaviate API key, my OpenAI org, and my OpenAI key. I'm going to print just to be sure that this worked. Obviously, I don't want to print my keys, but I can print my Weaviate URL because you won't have access to it anyway, just to make sure that worked. And that worked. So this is where my Weaviate cloud is. Now, I'm going to pip install Featureform and some other things I need. Great. Next, I'm going to create a client. Now, Featureform can be deployed. And if you deploy Featureform, you can connect it to things like Databricks and other stuff to actually run your transformations, build your embeddings, work on huge data sets. Now, Featureform also works locally. And local development allows you to, like what I'm going to do here, build and test things locally, play around with it, get a sense of the Featureform API. And for vector databases, you can actually write to an external vector database. So that's all I'm doing here. So run that. And then I will ff.set run. Pretty much what I'm doing here is I'm setting this default version for everything I'm going to create. And the reason I do that is such that all these things are kind of grouped together. I'll show you guys the dashboard. You'll be able to see how the transformations are built. But let's do that. I have a directory, data/files, which has all of my all of the transcripts of all of the podcasts that we've done. So we have a podcast called MLOps Weekly. I just took all of the transcripts and I put that, and I dumped them into a directory. So all this is doing is just telling Featureform or the local Featureform that, hey, I have this directory I'm going to use. I can call client.dataframe, which will just give me the data that I just registered as a data frame, which I see here. So these are the file names, and this is the data. You can also see this in the dashboard. So if I run Featureform dash, it will give me, that's interesting. If I run Featureform dash, which I'm going to run myself here, it allows me to look at my my dashboard. And so I set it up wrong, but I'll show you an example dashboard. So this is, it's going to look slightly different from what you'll see, but you could look at your sources, you could look at your transformations, you could look at a transformation like this. You can see how it was defined. If there's an error, this one has an error for some reason. You can see what the error was. This one's on Databricks. So I can look at Databricks and see what else is on Databricks, etc. Like features, training sets, anything else you'd have here. Great. So next, I'm going to create again, everything I'm doing so far has nothing to, like, it's not that has nothing to do with LLMs, but it's like traditional data engineering. And this is kind of the funny thing about RAG is every step of the way is pretty much exactly like traditional data engineering and traditional machine learning, except that we create an embedding and we store in a vector DB. Everything else is the same. And so all the same problems apply as you would if you were building large data pipelines for your machine learning models. All this thing is doing is it's taking the data set, it's breaking it up, and because right now it's set up in such a way where it's a full transcript. I actually want to chunk it so that each row is like one statement that a person said in the podcast. So I can do that. And again, I can see the data frame. So I can see here that in this file, I said, hey, everyone, whatever, my like opening at this time and ended at this time. And so this is the duration. So this just got built just via my transformations I've defined. Awesome. I'm going to create just a primary key on all these things. And all the primary key does is it just allows me to do a lookup on any single statement that someone said. And so all I do is I take the speaker, the file name, and the start time. That will make a unique ID that I can use for lookups. And there's 1,400, about 1,500 statements total in all of the podcasts. Okay. Everything I've done so far is going to just look like normal pandas. The way I decide to break up a document, that's actually kind of an open question. Like, how do you break up your documents? What's the right way to break up your documents? What size do you chunk on, etc.? This is something that you'll have to decide based on your data set, and you will probably want to test and evaluate many different approaches. It's kind of a variable, a hyperparameter that you can change. Now that I have this text, right, I have these like statements. All this transformation does is in pandas, we go through and encode it. We get this thing called sentence transformers. Sentence transformers is in Hugging Face, and it gets this specific type of model, mini LM, L6, and it uses that to embed the documents. Now, there are many, many, many different models that can be used to take text and turn it into an embedding. This is one of them. This one's pretty fast, and it's not an API call. So I chose to use this one. If you're using OpenAI, you can do that too. OpenAI has a lot of embedding models. But yeah, I mean, you kind of just do what works for you. So I'll run this, and it will create a transformation. So this will actually generate the embeddings. And actually what I can do is I can do client.dataframe of vectorized comments. If I run this, it will create that vectorized comments. And once it's created, it will actually give it to me in a data frame. And so you'll be able to see the embeddings that get created. So you see here, there's a vector. This vector, it looks like random, and it's not random, but it looks random to a human. But this is the embedding. This is actually a vector representation of this text right here. Someone asks, does it matter if I use a different model for embeddings versus the embeddings that the LLM uses? Great question. So going back to here, I take my query, I create an embedding out of it. There's an embedding model. On the left side, I pre-process my text using an embedding model. Those two embedding models have to be the same because they think of it like a mapping function. Like I take text and I map it to this embedding space. Every embedding model has a different embedding space it maps to. So if I use two different models, they will, like the text I embed, if I embed the same text with two different models, I'll get two very different embeddings. If I embed them with the same model, I'll get the same or similar embeddings. And so you have to use the same model to embed them. Now note that the model that you use to embed is not an LLM or rather, it's not something that you like prompt and chat with. Like ChatGPT does not, you can't use ChatGPT directly to generate an embedding for you. Now, ChatGPT uses embeddings internally, but that's not really relevant. But an embedding model, sometimes called an encoder model. So like if we go into here, you see this left part, encoder only. Encoder models are models that encode text into an embedding. GPT, which is on the right here, is a decoder model. It does not output an embedding and outputs text. So there's separate models. But if you want to do a similarity search, you have to embed both pieces of content with the same models. That's a really good question, and actually a really common place where people will come up with bugs. They're like, oh, it's not working. My similarity isn't working. It's like, yes, you have to use the same model. Otherwise, it's like using two different hash functions. Like they will just not give you the same output. Okay. Now, I'm going to register Weaviate. So I have a Weaviate cluster. I have an API key. I'm just going to register this. Next, I'm going to write my embeddings and the feature. The feature is just the text that I use to create the embedding into Weaviate, or the vector, the embedding is going to go into Weaviate. So I can use that to look up a primary key based on my embedding. Now, this operation, I already did this because I didn't want this to take a few minutes, but if you run this yourself, if you have a sandbox Weaviate, which is like really, really tiny because they give it for free, it could take like 10 minutes to write even just only 1,000 things. That's just because they really give you a small thing for free, which makes sense. It's free. Now, yeah, anyway, all this does is it writes it. You'll get this kind of like loading bar, and then eventually you'll get to 100%. Awesome. Okay, so now in Weaviate, I'm actually going to sign in. Yeah, I'll just, it's fine. You guys can't see it. Here, I'm going to stop sharing so I can sign in without. Okay, so I just signed in, so I'm going to start sharing my screen again. So I need to put this in the same tab as that. Okay. Share screen, share, boom, got it. So here's my cluster. I actually am not super familiar with the Weaviate client, but if I look at details, you can see that I have 1,400 embeddings in Weaviate in this cluster. And you can see that I've done about 4,000 embedding queries based on that. Cool. Now, everything I've done so far has been going back to my like little thing, has been on the left side here, has been filling my vector database. In this workshop, I didn't focus on the inference store as much, but you can see that I've created my vector DB full of documents. My documents are statements that were made in the podcast. I embedded them. I put them in the vector DB. Now I need to do the per request stuff, which means that on a query, I have to embed the query, get the relevant text, and then then build a prompt from that text. So let's do that. So if we go back here, we have this idea of an on-demand feature. An on-demand feature is a feature that's built at request time. I can use on-demand features and other on-demand features, which is what I'm going to do here. But here's a simple on-demand feature. It takes a parameter, which is the query, and it just does a client.nearest. Client is the Featureform client. So it does a client.nearest. on the content embeddings version webinar, which we created up here. Using the search vector, again, the search vector is actually my query encoded via this transformer, this model. And then I use that to search. And I just want the 3 closest things for this example. So I run that, that creates it. Now I can run this. And my query is enterprise MLOps. So these are 3 statements. So my statement at 13 minutes in the Lear and Hassan webinar, or rather workshop or podcast is relevant to that. If I change this, if I say like testing stuff, or just testing, I got completely different ones. Now I have one of Sam and I have 2 of Josh Wills. So you can see that my context is going to change based on the query. Now, I need to take this stuff and turn it into a prompt. So here's what I do. In this on-demand feature, I take the relevant comments, so these 3 things, for the query. I build a prompt, which is just a string. Use the following snippet from our podcast to answer the following question, new line. I loop through the things. I then put question, colon, space, the question, question mark. So this is the prompt I'm going to feed ChatGPT. And you can see, if I run this and I do enterprise MLOps, it will say, this is the actual prompt. Use the following snippets from our podcast to answer the following question. The second question, this is a statement. This is another statement. This is a third statement. And then question, enterprise MLOps. That was a statement. Or how do I implement? I implement enterprise MLOps. So if I run this, I'll get a slightly different one. I'll get these different comments. That's my prompt. All RAG did, I say all because it sounds simple, obviously it's hard to do, is grab relevant information to my question, how do I implement enterprise MLOps? And then it built a prompt using that information, that context it gathered. And now, if I ask, what should I know about MLOps testing? I can use the feature I defined. I can pass a query in to get the prompt. When I import OpenAI, I set my organization and my API key. This should be OpenAI org and my API key. And then I create, so OpenAI completion, I create, this is using the DaVinci model, which isn't ChatGPT, but similar. And I give it a prompt. I give it max tokens, which is how much stuff it will print out. And then I can set the randomness. This is just OpenAI. So all this stuff is just OpenAI stuff. Featureform is just a way to build that contextualized prompt. So I can run this and answer. MLOps testing involves monitoring the entire lifecycle of model from experimentation and data ingestion, tracking, training, and deployment. It's also involved. So anyway, if you were to write this question into DaVinci without the prompt or without my special prompt, you will get a different answer. So anyway, that's RAG. So we just did it. We went all the way through. We built embeddings from a base text set. We defined, we put in VectorDB, we did a lookup, we built our prompt, and then we fed that prompt into the LLM. This is RAG. Featureform was the way to define all the steps. So now there's lineage. I can look at a prompt and I can see the steps to build that prompt. If I needed to run this on Databricks, it would be very, very simple to switch this to use Databricks instead if I have a giant data set. if the data changes, you can set up Featureform to run on a schedule or to run on streaming data, etc. So Featureform is the orchestrator. It's almost like you have all these pieces that I just showed you, like Hugging Face and Redis and Spark and Pinecone and Weaviate and OpenAI. And these things are all necessary. But what's missing is this orchestration and metadata framework that makes all of this stuff work together cleanly so that you can build and update and version and govern and manage and deploy your LLM applications. Awesome. Well, that's all I got for you. I obviously left a little bit of time for questions if anyone has any questions. Feel free to throw them in Zoom or in the Zoom Q&A. I think Shab is watching the LinkedIn and Twitter if there's any questions there. But yeah, if you're asking a question, I see some people like raise their hand. There's actually a Q&A thing. If you look at, it depends on how your Zoom looks, but maybe at the bottom of your Zoom screen, there'll be a button that says Q&A. I believe that's how it will look for you. And you can use that to ask questions. Give a few minutes. It takes a minute to write them down. Okay, I see a question come in. Have you had any success on getting LLMs to leverage both pre-trained data and the contextual information? I see when I provide context, it will only leverage the context and not what it already knows. Yeah, so when you give it context, it will also leverage what it knows. Like it will use both. Now, if you have, I think what you're asking is like, can you use fine-tuning next to, like fine-tuning is this, right? Where you have like a data set, you're fine-tuning it. What this does is, see, the LLM by itself already knows a lot of things. And if you contextualize the prompt, from its perspective, it has no idea that there's RAG. From its perspective, it just has a prompt and it answers it. Now, we know that that prompt is actually contextualized. If you want the model to behave differently based on a prompt, you can fine-tune it to teach it. And that's fine-tuning. RAG is just updating the prompt. So like you can think of fine-tuning as updating the model and RAG is updating the prompt. And you can do both of these things together. And I know that a lot of people do both of these things together. There's not a ton of data around like what works, what doesn't work, like evaluation is an open question. The two open questions for LLMs right now is data, how do I use it? And two, how do I evaluate my system? So we solved the data part, but the evaluation part is still an open question. So this is a really fun one. I had strangely an I don't know answer after using RAG of my own data. What could cause such an answer? Although the reason I use it is to avoid such cases. That's really funny. This can happen. This is maybe like the biggest problem of LLMs is they're so hard to make work right sometimes. And the answer, so let's say I found that sometimes my model responds, I don't know, when I contextualize it. I would actually change my prompt. So I would change my prompt to, you put the question at the end, and then you might add a statement, which is, if you don't know, or you're not sure, try your best and let me know, and let us know that you, or let me know that you aren't sure. So you can actually, this is the prompt engineering part, and this is where it's kind of creative. Like you can tweak the prompt to make it do what you want. If I saw an I don't know answer, it's really hard to say why I would do that because I would really have to look at the prompt. But even if I had the prompt, I might still have no idea. But the answer is typically play around with your prompt so that you can make it not respond that and give an answer. And typically that's going to look like saying like, don't say I don't know, or like you must give an answer or something like that. That's a fun one. It's a great question. I've answered 14 questions. This has been awesome. Lots of really good questions. Any others as we're wrapping up here in the last few minutes? I'm also just gonna, as maybe someone's writing something down, but Shab, maybe you can speak to, we're gonna send some stuff after. I will include the GitHub link you can follow. We have a Slack community that you can join and ask us questions. Shab, I'm probably missing some stuff. You wanna jump in?
Yeah. I'll send a follow-up with a link to that. Link to the notebook. We'll also include a survey in it. We'd love to get your feedback. We're always trying to improve these events. And recording of the event itself in case you want to revisit any points.
Awesome. Cool. I'm gonna hang out for another couple of minutes until, or I guess another minute. If there's any last questions, this is the time. Obviously, you can always just email me. I'm simba@featureform.com. You can always, you can email me. You can find me on the Slack community. I look at the Slack community. So if you do ask questions there, someone on our team or maybe me will answer them. But I hope this is useful. Thanks. It looks like almost everyone's, like a lot of people stayed for the whole thing. So hopefully that means it was interesting and that you didn't fall asleep. But either way, thanks for coming. And Shab, I'll make you host and you can take us off. Someone asked, can I share the notebook? It will be shared. There's a GitHub link that you'll be able to do to get the data in the notebook. Thanks, everyone. Thank you.
All right. Thank you, everyone. Bye.